Please welcome first-time superhero Patrick Schiefer. Today he'll be showcasing premiering content in his session, Design Patterns with Object-Orientated Approaches. Please stick around after Patrick's session for a live Q&A.
Hello and welcome to my session at DynamicsCon. Thank you for letting me present here. My name is Patrick Schiefer. I'm a software developer for about 12 years, blogging about Business Central and Azure DevOps. You also can find me on Twitter. You can see my name here. Today we'll talk a little bit about design patterns with object-oriented approaches in Business Central. So what we are then talking about is, first of all, a little bit general about object-oriented programming, then about the solid principle. Some of you may heard it. It's a common principle in object-oriented programming. And we will also talk a little bit about 4 concrete design patterns. I know there are much more, but we have only short time, so we will focus on these 4 design patterns today. So let's start with a little bit general. So object-oriented programming is a programming model where we focus around the data and objects rather than functions and logic. What does this mean? This means that everything we talk about in our programs, we think about in objects. But we talk about 2 terminologies, mainly about classes and objects. A class is a definition of data and available procedures, and an object is an instance of a class. Well, if you know Business Central and AL, you know that there are not really classes. So there are 2 facts about AL. AL is not object-oriented, but it uses .NET as an underlaying technology. And knowing about these facts, you could use object-oriented programming in AL. I will show you later, but first, talk a little bit about value and reference types. A value type is a variable or a data type where the value of the variable is stored directly at the memory address. So if you have a variable of integer, the value of it is directly stored at the variable. If you have a reference type, the variable only includes a reference to this to the instance of this variable. Okay, what does it mean? I have a small example. First, how does a value type behave? We have on the left side a little code example with 2 integer variables. First, we assign 5 to the first variable, and then we assign the second variable with the first variable. When you see on the right side, both variables show the value 5. So when I change the value of B now, it doesn't affect A. Quite simple. So now we talk about reference types. Every object, or nearly every object in AL is a reference type. I haven't tested all of them, but I'm quite sure that all object types are reference types. Here I use a code unit, and I have created a code unit which presents integer. So we have a function set value and get value, and of course as an instance variable we store the int value. On the right side I do the same as before. I set the value of A to 5, then I set the value of B to A, and I change the value of B. So let's start. First of all, we see A and B now pointing to instances. The instance value of A is 5. When we now assign P, the second variable to the first variable to the second variable, the instance of the second variable is deleted by the garbage collector because now it's garbage. It isn't needed anymore. And the second variable is also pointing to the instance of A. So now both variables pointing to the same, and the change of B also affects A. This means when I start with a message, when I display a message of the value of A, it is 10. So knowing about this behavior helps us to understand the design patterns I will show you afterwards. But now I want to talk a little bit about the solid principle first, because I will reference it later a little bit in my patterns. So solid stands for single responsibility principle. This means every class or every code unit or every object has just one responsibility. Open-closed principle means that every class or code unit or object should be open for enhancement, but closed for modifications. The Liskov substitution principle means that if you substitute a logic, so if you use another object, for example, maybe the price calculation in Business Central, if you substitute the price calculation, it should do the same as before. So maybe it does it different, but the outcome should be the same. Interface segregation policy means that the interface should only include things that are necessary for the caller. So don't confuse the client with too much details, only set procedures to public which are really necessary to call. For example, if we talk about the price calculation like before, we don't need functions for getting lines or something. We just need a function which is called calculate. Therefore, the interface should only include a function calculate and not all this other stuff. And dependency inversion principle, which is also a pattern I will go into detail later, means that high-level classes should not depend on low-level classes. There's some confusing description. It means more or less that two classes should not directly depend on each other. So we can put an interface between, then we have a loose coupling between those two classes, and we can change both without affecting the other one. The template method pattern is a pattern to solve similar problems in a similar way using interfaces, and the template only calls functions or procedures from the interface and not directly the function. So the implementation is completely separated from the template, and it could also be used to improve the testability of your app. I will show this in my example later. First, I'll show you how a bad code for this problem looks. A common problem we often solve is exporting data. When you think about exporting data, we have mostly check data. We loop through data, and then we write data somewhere. Okay, it's quite an easy code, but if you want to extend this code, you have to increase you have to add more enum values and more code to the cases, and the code is getting larger and larger. So now I will have you a little hands-on on this example. So I've already prepared 2 apps, an app and a test app, where there is no code in there. Okay, how does a template look? First of all, I told you we need an interface which has the functions for the template. Okay, I call it interface simple exporter. Okay. Okay, we said we have a function check data, returning boolean, procedure, this a little bit. We have a procedure check lines, we have get lines, process lines. We loop through lines and we export data. Okay, now we generate a little template where we call this interface. Now we have a code unit with one function. This function is doing more or less the same as our example before. So the bad code example from the presentation was about checking data, getting lines, loop through data, and process the data, and afterwards export the data. Okay, when we look at this template does exactly nothing at the moment. So I have a little example. Switch to it. So now I have an implementation of this. And as we see, I implement the iSimple exporter. I also have here a function set document filter, which is not part of the interface, because my code unit can also, of course, include functions which are not part of the interface. But this procedure is not available through the interface. So we also have check data, check lines, get lines, process lines, move next, which is literally only set the record to the next and the export. Okay, now we can call this export with the code unit as a parameter, and then we will export this data. So when we have a look here, I have prepared this example. The simple export just looks like this. We have a code unit, simple export data, which is the template. And we have an implementation for the sales line, which is exporting the sales line. I set the document filter, and then I call export. That's everything we have to do. Let me just create a launch JSON. Okay. So now I should have a launch JSON. Yeah, here it is. Download symbols. Okay, now I can call it. So now on the sales orders, and if I call the simple export, get the message with the exported data, because in my implementation I just give a message here. I can also implement here a web service. So if I make a second one, of course I need another number here. Web call, and then I can do the same thing with export data to a web service. But the main logic stays the same. Okay, that was the simple template method. But as I said before, the template method pattern can also be used to improve the stability of your app. So I've also created a complex example. The complex example differs in the interface. So I now have not one interface. I have one interface for every responsibility. When we think about the solid principle from before, we have one responsibility for every interface. So we have data check, get lines, process data, and exporter. And the template looks more or less the same, but now I can pass 4 code units or interfaces, and then I can export this whole thing. When I look in the implementation, it is more or less the same. So I have the get lines, I have the document filter, the move next. I have the data check, which is exactly the same. I have process data, which is also exactly the same, and I have an export to message. Now, if I want to do the same as before, so when I want a web call, for example, instead of a message, I just have to copy this one and say complete export to web call. And now I don't have to copy the whole code unit, which includes the whole get and process code. Now I only have to change the export code itself. Look to the example. Now it's more or less the same. I have a complex export. It's the same output. At the moment, there's no difference. So why should I do this complex stuff if it doesn't make a difference? Because I already said testability. What I have done here is that I have created a test which is mocking the sales line complex getter. This means that we have here our own getter function, which is just faking the get of the sales line and includes fixed data to process. So we can test the process and the export without have to rely on the data, because the data is now fixed and we can just test if the export and the process works. Also, the move next returns fix null 0, because we just have one data and we have just one record in the data set, and we don't want to iterate it through it. So now I can call the test. I have my complex test here. Okay, now if you have a look at the complex exporter test, it has an error. Okay, why it has an error? Because when I have a look here, maybe I have a look at the export, we are generating a message here. Now I have two possible way ways to solve it. I can, of course, handle this message if I want with a handler function, but I'm not really a fan of the handler functions if it's not necessary, because at this test I just want to test if the processor is returning the correct data. So what have I done? I have created a mock for the complex export, which is called no export because it does nothing. When I go to the test again, just switch the exporter to the no export from the message. When we have a look here, check the exported data and compare it to a fixed value, because as I already said, the mock getter is generating a fixed sales line. Okay, let's run the test again. Now it is successful. It takes 3 milliseconds, so it's quite fast because it's not getting any data really, so it's only processing the data, the fake data. That's a quite cool way to test small portions of your software. For example, I could have a second test. I will not fully implement it now, but I could have a second test where I'm not mocking the complex data getter, but maybe I will mock. Maybe I will mock the sales, mock the complex data check, because I want to check the complex getter if it is working and fake everything else. So this is more or less everything about the template method pattern. If you have any questions, feel free to write it in the chat. There will be a Q&A after the session where we can answer these questions. So go back to my presentation. We'll now talk about the comment pattern. The comment pattern is a behavioral design pattern, so you control the behavior of your program with commands. Using this pattern, you can create components which are calling code without knowing which code. I will show you an example in 2 minutes. You can also write more flexible code, and the pattern is containing at least 3 elements. You have a comment interface, a comment code unit which implements the interface, and a commander code unit which is invoking the comment. So of course I have also a bad code example here. If you think about a code unit which is posting something, we have maybe a function which is called post sales document, and then we have a function which is called post and print, and then we have post and export to file. So what's the problem with this? If you have new actions or new comments, you need to add, or you need to modify this code unit. So it is not really flexible because you have to change the source code unit which is calling this. When we look at the pattern, let me show you, it's more simple than the previous pattern. I have one interface. It only has one command. It's called execute. In my example, the execute has no parameters. Of course, you can also have some parameters which are necessary to execute this command. But as I show you in the example, you can also have additional procedures in your implementation code unit of the command. So let's have a look at the example. I have, of course, a comment For example, I have an EDI order confirmation comment, which is implementing I comment, and I have an execute function, which is calling the export code. As I said before, you can have here parameters. Then you will have, for example, document number here. Of course, you then need to add it in the interface. And then you don't need this function. But this only also reduces flexibility of your code, because then you could only use this interface for comments which are related to documents with code 20 as primary key. When we have this example, I have also a second one, which is doing a print of a sales order, like the previous example. And now I also have a procedure post, and I give a sales header to it and pass a comment to it. And afterwards, I do the post. So the comment is only executed if the check was successful. And you could also use an event here instead of the comment, but the advantage of the comment is that you can control which comment is executed. So if you want to have, like in my example, 2 different comments, it is not so easy to solve with events. Then you need manual bind of the events, which adds a little bit of complexity. But I will show you in my example that this is working quite well. I have, of course, here my comment example. I have a comment example with EDI. It says to do implementation, and I have a comment example print, which is calling print. When we look to the page, it is quite simple. Both of this example look the same way. So we have the print command, set the sales order. We call print document, and we call post document, and give the print comment to it. Yeah, same thing for the EDI. Works pretty well, and you have flexible code where you can pass every comment. But what if you want to do both? So if you want to print and you want to send to EDI, then we would need more than one comment. But if we think about flexible code, we don't know how much comment we need. So we need some kind of structure where we can pass as much comments as we need. So which brings me to the next pattern. When we go back to my presentation, it's the common queue pattern. It's a pattern where we can combine comments to a queue and execute it in order. It's used to control the flow of a process, and it can combine single tasks to a greater process. So there is no bad code example for it, because we have more or less seen it with the previous pattern. So now we have a look at the pattern. We have a comment queue and a queue entry. I will describe it in more detail in 2 seconds. And I'm using the iComment interface from the previous pattern. So this pattern is an extension for the comment pattern. So what is the queue entry? The queue entry has a value. The value is the iComment. You can get the value here, which is returning the iComment. And we have a next entry. And we can set and get the next entry. When we look at the comment queue, we have two important functions. One is the push, which is adding a comment to the queue. It sets the first and the last entry, and it combines the entries. I will not have a visualization of it in 1 minute. And the pop is taking the first value of or the first entry of the queue, returning it, and remove it from the queue. So it's a first in, first out principle. And of course, we have a function which is processing the queue. It is looping over the queue as long as the size is greater than 0. Pops the first object and executes the comment. I will show you a little visualization of it. So in the queue, we have a first and a last queue entry. When we add the first queue entry, both the first and the last, as we have seen in the code, are pointing to the new entry. This picture shows the second entry. So if you add a second entry, the first points to the first, of course, the last to the last. And the first is also pointing to the next one. So we have a linked list. So if we add another one, the last one, so the new one is the new last because it's a first in, first out. So the last one added is also the last in the queue. And the previous last entry is now pointing to the new last. So when we look at the code, this is exactly what we do in the else when we already have an entry. We set the next entry from the last to the new entry, and we set last to the new entry. Okay. And now we want to pop. So when we pop the first entry, the green entry will be removed. So what is happening? The first is now pointing to the pink one, and the last is now pointing to the yellow one, and the green one from the previous picture is now removed. So this is exactly what the pop does. So it returns the value of the first. The first is now, the first gets set to the second one, and the count is reduced by 1. Okay, so that is how a queue works. Let's see the example. I have a posting comment. Oh. Sorry, this was another one. I have a post document queue example where instead of a comment, I pass a process queue now, a comment queue now. When we go to our example, what I do here is I have a queue, and to this queue I add via push the EDI command and the print command. So now it is executed. It executes both. I can also add more commands. I can also add a command twice. So if I call it now, we will get the message of the EDI command twice, and the print command is executed once. Command queue example. I get 2 messages, and the print is already open in the background because the messages are not blocking, and the printing is already executed. Now I will come to my last pattern for the day. It's the dependency inversion principle. It is reducing dependencies between objects and apps. and it uses interfaces to connect objects and apps. It's a loose coupling, so you couple two objects via an interface. Thinking about this dependency tree, we have one generic library app, we have a pricing app, and a sales app and a purchase app, which are depending on the pricing app. When the generic library app is updated, every of these three other apps has to be reinstalled, because sales app and purchase app has an implicit dependency on generic library app. So if you have installed many apps, this can get a huge tree. When you want to reduce it, you can use another app, or in my example, I will not really split it up in apps, I just have separated in different folders. I have a baseline app with an interface here. I have all other apps connected to the baseline. So every app, so for example, the pricing app or the purchase app, are communicating via the baseline to other apps. So the pricing app doesn't really know the generic library app. It doesn't really need to know it, because I will show you in my example, they are working independent from each other. The baseline itself includes no code. It's just interfaces, or at least at the maximum a little bit of setup code. Update should be very rare, so if there's no code, and you should not often update the baseline. And you could add easily new apps without adding complexity to the dependency tree. Now I have another hands-on here. Okay. I have a baseline, as I already said. Baseline includes an interface for the price calculation. It has one function, get price, and it has also a function, price calculation enabled. The baseline itself has a default implementation for this interface, which has the price calculation enabled, returning false. This means we don't have really an implementation, but we can check if there's an implementation available. Yeah, there's also some setup code, like on install code, which is generating a setup table. This setup table, it is defined which price calculator is active. And we have, of course, the enum. And the purchase app is using this setup to calculate. So when we go to the purchase orders now, we have an event on the quantity and on the number. When I change the quantity, nothing is happening, because when we have a look back here, I'm checking if the price calculation is enabled, and only if it's enabled, I calculate the price. So I have a second app, which also has an implementation for the price, which is saying price calculation enabled, and calculates the price, and an enum extension. And in the on install code, I'm doing the price calculation. So because I want the on install code to be run, I have to set the schema upgrade mode to recreate. Now I'm executing the pricing app. Now my code is executed, and you have seen the one app, the first app will work without the purchasing app, but when it is installed, the automatic it's getting executed. And that also if there is no dependency, so this app doesn't know about the pricing app. Okay, that were my 4 patterns which I want to present today. Of course, there are more patterns which you can have a look. There is the rguidelines.dev, which I have also added 2 of these patterns which I showed you today already. It's an open source project where everyone can contribute with own patterns. Then I've also linked the clean code developer, where I have copied the solid description from. And what I also want to mention is the Gang of 4 design patterns. It's a book. It has some of these patterns in a general way. It's not an EL book. It's a generic programming book. And there is also a book from Seaside, which I've not mentioned here today because I want to focus on the new technologies. That's why I have linked the IL guidelines dev and not the old Seaside book. Okay. Then now it's time for a Q&A. Just write your questions to the chat and I will answer them.